a student. I was doing at IIT Madras. Like, so now you see the scenario. Now it has changed completely, and the thing is like there is no OPC, and wherever you go and ask for a cement, people are coming and giving only the blended cement.
Yeah.
Okay, so that is what we have seen, that like what the problem is. Like earlier I came from the industry, like what I used to see, that the problem I used to face with the cement, I was working with the concrete division, and I used to interact with the cement division people, because I used to get the cement from my cement division people. So this is the argument I used to have with them. These people, the cement division people, mostly talk about the cement itself. Okay, they talk only about the cement itself. They talk about the IS specification. This is what mortar strength and all this. But ultimately, the problem is faced with the concrete guy whenever he's using the cement in the real-time application. Like Anil Pillai sir rightly mentioned, that we need to have a product for the right application. That is what in the first 10-15 slides you're going to see that actually. So this is how I prepared this presentation. So let's go ahead. We'll not waste much of time. So if you look at this slide, you can see that. So most of these ultimately,
yes,
of course, if you look at this, is completely. This is completely like when you look at from a cement manufacturer perspective, actually, he always looks at the marketing requirements actually. Okay, he always looks at the marketing requirements, and he wants to see who are the end users and who are the owners, from where does and what exactly the owner wants, and also he has to see for what application they are using it actually, because this is very crucial actually. So he has to look in a more. He mentioned that as a cement, okay, ultimately the cement has to perform in the concrete. Okay, ultimately we have to see for what application you are using, and you have to see the requirements of these specifiers for the owners or the end users you are using your material. You're using a cement or whatsoever material, and at the same time, it's not cement itself. We need very good quality construction materials, so they take the aggregates or the sand. They also play a very significant role. It's not that to have the right recipe, I need to have the right ingredients and the right proportions. At the same time, they should be adequately quality enough so that I'll get the right recipe. It's not that if my cement is really good, if as individually my cement is performing really well, but that doesn't mean that it will perform really well in the concrete. At the same time, I need to have the construction materials, the aggregates or the super plasticizers or the sand which are using simultaneously with my beautiful product of cement or a blended cement. Okay, they should also be of reasonably good quality. Then only you'll get the right recipe. This is what we need to look at. This is what we're trying to look at, and my whole presentation is going to focus on that. Of course, application. That is what I want to emphasize it. Like, I'm very happy to know that. I'm very happy to hear from Ramco Cement. Yes, they are building the products. I mean, they're coming up with the products based on the application need. The application is the most important product for any cement requirement. That is the crucial thing actually, because if you look at our standards, which we are going to see that, because they always talk about the cement, they always talk about the mortar strengths. Nobody talks about the cement strengths. They always talk about the test certificates, but that is not the case actually. What does this test certificate? Nothing. You're not going to get anything actually. It's all a bullshit. I will say it's a bullshit if you say the test certificate is a cement actually. Individual test certificate. It has to be when you are finalizing any product for a particular application for a particular project. The cement has to be tested though. No matter you test the individual cement as per the requirements, but it has to be a proven product in the concrete. Okay. Nowadays, you see that people have gone beyond the strength part, the strength-based design. Everything is gone. Okay, we are talking about the durability-based design, the performance-based specifications have come. Like you rightly mentioned that you're using this concrete for a particular application. Definitely, the cement is the main ingredient in the concrete, and it has to perform it. That is what we're trying to look at. The application is the most important things. And if you look at the cement part, you see this. What are the physical requirements? Definitely, this always you see the code. You see our IS code. Yes, definitely the strength. Okay, and you see the definitely initial setting time, final setting time. Sometimes the flowability, all these things on the cement itself, we know that. And other requirements, is it really the cement is quality? Is the cement is really consistent enough? Is the quality of the, suppose you are using a particular cement for a particular application, let's the project duration is 2 years. And let's say you finalize the product from Ramco, let's say you're using a Ramco PPC or some other cement. I'm not going to brand them. Some other cement, ensure that the quality of the cement is consistent. fairly consistent throughout the whole project. If there are a lot of deviations in the quality of the cements, definitely you're going to have a lot of deviations in the quality of the final end product. This problem I used to face when I was working in the industry from the cement division people actually. I really have a tough time whenever there is a change in the quality. Sometimes we don't know how much fly ash or slag, especially with the fly ash cement, they never reveal, the cement division people, they never reveal how much the blending. Okay, the test certificate says something, but truly speaking, that is not the case. Okay, and also there's a lot of variation actually. Sometimes it is 20%, sometimes it is 28%, sometimes it is 30%, 32% like that. And because of that, I cannot change my mix designs very often actually. This problem I used to face a huge number of times. That should be avoided. And of course, the durability has to be the prime criteria. Wherever you see that, like you said, that application, like if you look at the IS code also, people talk about where exactly you're going to have your structure. Is it near to the coast? Is it in a very severe environment, or a moderate environment, or a mild environment? So based on that, you're going to design your design, and based on that, you're going to have your final end product actually. So ultimately, these are all the minimum things which you need to look at, the strength and all as per the coded requirements. But ultimately, you have to test that product, the cement and the concrete, and you check the final durability of the concrete rather than checking the individual material, the quality of the material, like the strength and all. These are nothing actually. Because nowadays, with the present day cements, with the present day cement plants we have in India, okay, I have seen some of the plants. Everybody has upgraded their machinery. Actually, everybody has the cement machinery, and fairly everyone is coming up with a good product. So no matter whatever maybe there's, even if you put something in the concrete, some cement definitely are going to get the strength. Strength is not an issue at all in the concrete also. But ultimately, we have to talk about the performance. That is what we're trying to look at. Now you see that people, when you're talking about the high performance concrete, the scenario was different, like, okay. But nowadays, what the new thing which is coming up is, recently I was interacting in Mumbai in January. I went for a program. They're talking about that even if you make a 20 megapascal concrete, it should have the highest durability. Okay, that is what they're talking about. Even if you make a 50 megapascal concrete or a 20 megapascal concrete, it should be of high performance. That means the definition has changed. The people are talking about that I need to have so the definition of the high performance concrete is it should have the highest durability for any given strength. Okay, the things have changed dramatically. So the 20 megapascal concrete, if you use a slag cement with 60 or 70% of blending and all, definitely, though you have a strength of 20 or 30 megapascal for 20 megapascal concrete, but at the same time, your requirements of the durability will be really relatively low. This is what we're trying to look at, and we're talking about the concretes of that nature nowadays actually. And definitely, the customers actually ultimately what we need to do is the application. Like very firstly, he mentioned that we need to see for what application you're using the product. Based on that, you have to suggest. The cement division people also help the people, okay, who want, let's say somebody comes to some cement guy said, I want a particular cement I'm using for a particular infrastructure project or for a non-residential project or a residential project, please suggest me a product. Definitely, they should be in a position, like all the technical team, they should be in a position to assist the people, and they should give the right product for the application has been designed. That is the key of any project. Like if you look at this, just scroll down, there are a lot of applications actually. Ultimately, you need to prepare a cement in such a way that it should have the good workability, it should avoid the segregation, okay, and if you take the mass and for each one has own requirements. Let's say somebody has finished the whole structural work, okay, now he's going for the partition works, okay, the infill walls and all this. Definitely the plastering works or the bricklaying, this thing and all, definitely he has a different requirements. He said that, sir, I need to have a similar plastering and the brick work, I need to have a good workability, at least a very long setting time is required, and of course, strength is not a criteria for me. So definitely you need to have a product for that. So these are, so each for the application, every product is application oriented. Similarly, yes, when you're using a concrete, when you're using elements like mostly the structuring or the columns or the slabs or the load bearing walls, whatever load bearing columns, definitely each has its own criteria. When you go for a very high rise structures, definitely the strengths go up to 80, 100 megapascals. Because it is Mumbai and all these big cities, definitely the requirements are also different. They need to have a high yearly and the final distance development. It should have the highest workability, and sometimes we have a lot of reinforcement because of this reduced section. Definitely, okay, definitely have a self-compacting bit of good advantage actually. Similarly for the slabs, we need to look. So if you want specification, if it is to remove at 14 days, definitely it should have a good workability, and at the fairly nearly 60 to 70% of the strength should be achieved at the 7 day, so that I can remove a prof so that the structure will hold on its own actually. Similarly, everything has a requirement actually. So every application requirement, the concrete requirement. Okay? So to make the concrete requirement, and you should be ready with the right product for the right application. That is what I'm saying. And the precast applications, if you look at all these active and all, the most of the precast is the early strength actually. They want to have the high as early strength as possible, and what are the mechanisms I need to have. Like if you look at some of the blocks and all, they talk about the high early strength in the first day itself, than the specified strength. And sometimes you may go for this pliers or the GGBs, some metal components as well. And let's say you're using a sewerage pliers, definitely you're going to have a circuit resistant cement, and there the slag percentage is somewhere around 60-70% actually. Okay. We need to look at all this.
Can I intervene, sir, for some time?
Yep. Please.
Yeah. Because in fact, I just wanted to share our Ramco's experience also with precast cement. In fact, what had happened was that we were also looking at various precast manufacturers in the various parts of the country, and we also could understand that the requirement is a fast gain of strength. They wanted to remove the mold as quickly as possible, and at the same time they wanted to decrease the production time. And that is what rightly you have mentioned about the 1 day compressive strength, which our Ramco super fast. In fact, we had designed that cement specifically for this application. In fact, that's a good point. In fact, we also saw this observed in the field also, same thing. So we have been able to give this, and many of the precast manufacturers are able to look for themselves the benefit of this.
Yes.
I think that's the most important point,
That's what I want to emphasize actually. That's what I want to emphasize. Because, so these requirements, these are all the prerequisites actually, okay, for any product actually. In fact, like this is what every cement company should do actually. That is what I want to emphasize. Some of the cement manufacturers, I've seen that big cement manufacturer, I mean, they don't bother about all this. They always look at the business. I mean, business is also important. At the same time, you have to see the customer need right product, only one product for all the applications actually. Okay. And of course, when you definitely you have different requirements. Look at the color of the uniform color. There should not be any. It should not look. It should not fade away the beauty and all this. Okay, it should be light color. So all these requirements. That is what I want to emphasize. There, the requirement focus on the low water demand over the shrinkages, the fast setting and the strength development on the rapid. At the same time, you have a good body. This is what we need to look. And you need to have a product which will match the requirement of the industry. So when it comes to the mass concreting application, definitely when talking about the dam construction or a mass concreting application where you're going to use a huge volume of concrete in a single pour, like you see this raft foundations, the pile rafts normally, there are sometimes the pour goes up 2, 3 or 4 days actually. Continuously they pour the concrete to avoid the spoil joints and all this. There the requirements are different. The requirements is, okay, you need to have a low heat of hydration. Earlier the scenario was people used to have the low heat Portland cement, but nowadays it's not mandatory, it's not required, because not a single manufacturer, not a single company I remember the manufacturing all this. So what we need to do is we need to have a cement, okay, which should have a low heat of hydration, but you can use this fly. It will depend on application. At the same time, simultaneously along with that, you can use some ice utilization also, so that your application is matched, so that there will not be any thermal shrinkage differences between the outside temperature and inside temperature, and of course, and there will not be any cracking in the concrete. So these are some of the issues we need to look at for various applications. You know, single product, single cement for each and every application. You have to see the need of the project. You have to see the end users' requirements. Based on that, you have to act.
There are a couple of questions. In fact, one question that is being mentioned is heat of hydration mentioned in the test certificate. In fact, as of now, we don't mention the heat of hydration, but we test it at our research center. That is a very pertinent point that has been mentioned.
Yes. Actually, that is what I was telling. Whenever you have a product, please don't rely on this test certificates. Okay, this is as for the quality
certificate alone. Yeah.
But ultimately, whenever you're finalizing any product, you test this product for that application in the lab. Like you mentioned that before that, you take the product to the real application, okay? You test the product in the concerned lab. You see that whether this product is really meeting the requirements or not. That is very crucial actually, okay? So that is
one more question is one day mentioned in the IS code in the cement test certificate. Even one day normally we do not mention except in RHPC, rapid hardening Portland cement. There is a provision for mentioning one day strength. And
yes,
other types of cement we don't have the provision, but it can be always tested. As
yes,
you rightly mentioned, whenever we are going in for precast applications, I think one day strength has to be tested, and then we need to convince ourselves about that.
yes, we need to look at. So that is what you have to first. You have to convince yourself. Then you assign the product. Then you convince the people. Then you make them comfortable. Yes, this you have, and if you want, you retest once again, and
yes,
you prove that this is what it will really meet your requirement. That is what I want to emphasize everywhere actually. Okay,
correct.
so this is what. And also, definitely nowadays we talk about the durability that you mentioned initially. Now things have gone beyond our control. Everybody's strength-based design has gone completely, and people are talking about the durability-based design. Okay, so various, let's say you have this marine structures. Let's say you have a structure near to the coast. Definitely, there are a lot of fluorides and all this, and definitely, without any hesitation, I can say that. I'm not saying in the brand, you can use a Portland slag cement without any hesitation. I'll show you some of the slides, how much of resistance the slag cement is giving whenever using the cement in for marine applications actually. Okay, that we have proven. We have enough number of data, enough from my own lab itself actually. We can go for the sulfate resistant sulfate resistant cement which is having a GCB of more than 60-70%. You can without any hesitation can go ahead. You can go and use that cement. The requirements of the standards. Mostly the requirement cement contents, the maximum water cement ratio, the minimum cement contents and all. And of course, this reactive aggregates is not a big concern in India. Also, bricks and parking decks. Yes, you need to have a low impermeable water cement ratio. They also decks in cement and all this. Okay. Now we're not having all this sulfate resisting cements and all this. We have only two cements. Either the fly ash based cement or the slag based cement. You need to test this products before you're going. This is what I want to emphasize as requirements.
There is one question which has been put up. That is, what is the purpose of mentioning a minimum limit of blending percentage in PPC? Like we have 15 to 35%. What is the purpose of mentioning a minimum limit? You know, that is from the durability perspective. We need to ensure that some percentage of fly ash is there. Any inputs from your side, sir?
Yeah. Yes, so 15%. See, the IS people, they always play the game. They always have a broad range. Okay, just to promote the blended cement, they will tell that 15. But 15% and 18, but 20% and all will not give you any performance in the concrete actually. I need to increase the blending percentage so that I will really see the performance of the fly ash in the concrete system actually. Okay, 15%, 18% or the 20%, we have seen that, okay, the performance is very meager actually, as far as the concrete performance is concerned. Forget about the cement performance, okay, English performance. So we nowadays see that, so for durability purpose, nowadays is that people nowadays, nobody is blending at 15-20%, sir. People are just around 30-35%, 28%, 30%, they are in that range. Every cement manufacturer, whosoever is manufacturing a PVC cement, their blending is always at around 27, 28, 30%, 32% like that. Okay? Some are even going. Okay? Just for the broad range, usually these codes, initially they started off with 15%, 20%, the blending and all, that has been retained actually. Okay, so that is why they have given this broad range. Okay, but my suggestion is, whenever you want to go for use a PPC cement, ensure that the blending is around 30% or 35%, so that it will really give the right performance as far as the durability. Ultimately, that is the prerequisite everywhere. That is my requirement. The performance is my requirement actually. The durability is my ultimate requirement. We need to look into
overall performance of concrete. Yeah.
Yes, the performance of the concrete is the ultimate goal of any cement manufacturer. Okay. And also the road stabilization is so each So like road pavement, so he has his own requirement. So he talks about the early joint cutting. This is what immediately within the final set you have to cut it. So all these things have to be looked into. So you need to modulate the product. Okay, you need to justify in such a way that yes, definitely. If I use this product in your this thing, definitely it is going to give you all these benefits actually. Okay, that is what we need to look at. So similarly for road-based stabilizers, all these things. So ultimately the requirement matters from the client. And also sometimes I already mentioned initially, though your cement is good, the other raw materials are really bad, ultimately the final product will be affected. Ensure that the other products, the aggregates or the sand which you are using or the admixtures which you are using, they should have the right and they are adequately of good quality so that ultimately your recipe will be good. That is what I emphasize everywhere actually. And also this, like sometimes the hot weather and the cold weathering, each one has its own prerequisites actually. Definitely when the hot weather competing is there, definitely I said go for a flash or a slag blending. You can use, if you're able to afford, you can use some ice. Okay, you can use some ice in the market so that your temperatures will come down. So cracking more frequent actually. Similarly for the cold weather, I need to have an extended set. So you can use some medium turning admixtures or some water resistant, decelerating, accelerating admixtures. Sometimes it depends on the project. Okay, so there's so many requirements are there from the end user actually. So many requirements are there from the application oriented. So we need to address in the right perspective. That is what I want to highlight here. And also this nowadays you see this. It's not only that. One of that is like we're talking about. See the way the cement, the quality is going on. The way the concrete technology is going on. Every day they're coming up to some new products and a lot of technology is taking place in the concrete. Similarly, on these simultaneous, there's a lot of work is going on the construction technology also. People are coming up with new technologies. Okay, the JCBs, like the concrete pumps. Okay, the vibrators and all this and all. Okay, so sometimes if you're building a high-rise structure, definitely, okay, I need to pump the concrete against the gravity and with up to the 50th or the 60th floor actually. Okay, concrete should be highly workable. I need to have the right recipe. I need to have the right recipe. Okay, so right recipe and to have the right product from the cement. Now, what some of the problems which I have seen in some of the sites, what I've seen. So I'll just 1 minute of time I'll take. The problem what I'm facing is whenever I go to any site, most of the problems come from the concrete.
Okay.
There is some compatibility issue, there is some bleeding, there is some segregation.
Cement and
the cement manufacturer says that he says, sir, the super plus I'm using is a good product. And the super so this is the fact they always say that, and they say that immediately whenever I go and do some postmortem, they say that it is really good. We have tested the cement. This is tested immediately for the highest codal provision. Okay, it is really meeting the requirements. Then here the question my cement is bad. And the admixture manufacturer also says the same thing. So no sir, my product is also a product. I am so and so or Sika or BSF Homes. I am also from a reputed company. How can he name the product? So this is what nowadays the problem which you are seeing. Okay, application one, talking about the workability and pumping of the concrete. There's another issue which is coming up, which is a very crucial issue, is the compatibility issue. Okay, people see individual house builders, they never bother about all this. Okay, they never bother about, they simply mix something and all, they'll pour it individually. Somebody is building a house. But when you're going for a very big infrastructure or some high-rise products, housing projects and all, definitely this issue will come. The compatibility issue will come. A very crucial issue I want to emphasize here. It is something like the cement manufacturer says that my product is good, and at the same time the admixture manufacturer also says my product is good. But the problem arises when you are using these two. Definitely, you see some of the construction scenario in big infrastructure projects. Definitely. So definitely we need to look at. So these things have to be solved beforehand. That is also want to emphasize. So this compatibility issue has to be solved beforehand. Let's say somebody has finalized a particular brand of cement. To meet that requirement, the admixture manufacturer has to come up with a particular right product so that it will be compatible with the product, so that there should not be any issues in the future. This is one big problem.
Can I interrupt here, sir? For a moment?
Problem. Yeah, please.
Because when you were talking about cement admixture compatibility, as you rightly pointed out, there is always a challenge at the site level when we bring a cement and admixture together. So what we have done is that before the admixture is being used in the project, we try to take that admixture and cement and then make the specified concrete mix at our Ramco Research Development Center itself and try to see whether it is compatible or not. And if it is not compatible, we always coordinate with the admixture personnel as well, and also look at how it can be done. So that is one kind of support that we are giving to the construction professionals as well. That's a very good point that you have raised.
Wonderful, wonderful. Yes, wonderful. You see, some of the practical problems I see everywhere actually. Because I go to see some site visits and all, somebody calls me and say that, so there is a problem with my concrete. Most of the problems are with the concrete. See, it is something like you have to work out beforehand. You have to work out beforehand. You have to work out beforehand. I always say that in every presentation, there is something like a boy and a girl. There is something like a boy and a girl.
Correct.
Okay, like just individually, the boy is handsome, he's well qualified, he is good. Individually, he is good, and the girl is also individually she is good. The problem is not married actually. So they should be compatible after getting married. Yes, that is what I want to emphasize everywhere. And if you summarize all this, you see this. What is the different focus of the construction market in place? Definitely, if you look at the owners, they always look for the longer life cycles of the construction. It should better cost management. It should be cost effective. And it should be compliance with the standard. That is what any end user, any guy, any client who wants to have a building, any facility, definitely he is going to see all these things. When you come to the contractor side, he wants to save the placing and curing of the concrete. That is what some of the problems we face. They doesn't cure the concrete also. He wants to reduce the labor cost as much as possible, and he wants to reduce the repair and the rework cost. Okay, definitely. So that's every contractor whosoever working definitely is a businessman. Definitely he wants to make some business, but it should not be at the cost of the quality of the concrete. So the curing of the concrete and all these things all comes as it's more of a construction practice, not a technical issue. It's more of a practice. Okay. After that, the job is done. Now, after that, the curing and everything and all is more of a practice. That is why the construction practices should be good. That is why sometimes you see that the contractors, the selection of the contractors also plays a very significant role as part of the overall the quality of the structure is concerned. The contract, if you, let's say somebody is quoting very low, give it to him, then ultimately you have to suffer. Though he has completed the project, but ultimately within a year you go. That should not be actually. So this is definitely the problem. And also coming to the precast manufacturers, definitely like you rightly said, that optimum of production process. Anybody as a business person, everybody also looks into that. He doesn't want to have any failure rate actually. Okay. Improve the product quality surface. Definitely. In the precast manufacturers, the product quality will be fairly good because the quality control is within your reach. So they can maintain that quality control. That's not really a problem. So other issues also have to be met without compromising the quality. That is what I want to emphasize. Now coming to the RMC player, he has a different ballgame. For him, the only ballgame is the consistency of the cement. This I rightly mentioned initially because when I was with the industry in Mumbai, like I was working with a particular company in Mumbai, I faced this problem actually. Okay, we used to have a lot of fight with these division people. I was heading the concrete division people. We used to have a lot of problems because the problem is the consistency and the quality of the cement. Okay, that is what. So what happens? It reduces the variables in the mix design. That is a crucial problem I used to encounter everywhere. My plant people used to encounter everywhere.
Yeah.
So whenever you were talking about, let's say, because we were asked to use only the PPC cement for all projects, and you see there is no consistency in the quality of the PPC cement. Sometimes I don't know how it comes the cement. Sometimes it's 18% blended we test in my lab. Okay, sometimes it is 28%, sometimes it is 20%. So there is a lot of variation from week to week, and ultimately we are the sufferers. The concrete division people are the sufferers. Okay, they have sold the cement, but ultimately we have suffered a lot, and we could not able to, and we used to play a lot of penalties to some of the big contractors in Mumbai and all this. So this is the requirement. The cement division people, whenever they're supplying, my suggestion to all the cement division people, whenever they're supplying any cement to a ready-mix concrete player in a bulk quantity, and ensure that it should be a good quantity so that you will not face any problem. Ultimately, the concrete that the RMC manufacturer should not offer. Say 1-to-1. I have given the cement, I got the money. No, that is very important. Everyone has to look into that. Okay. So the meet specified concrete performance of the lowest cut, definitely. Ultimately, I should have the right concrete performance at the lowest possible cost. If you look at the standards, you see that, okay, that is what I will tell that the cement producers focus more on the mortar testing.
Correct.
of the motor testing, everything. No problem. You test the motor as per the IS specification, everything and all. Definitely, you get a strength of 53 or 54 or 56, whatever. The 53 get no. But ultimately, but for end user requirement, nobody uses a motor. Okay, it has to be used in the concrete, so it has to be measured. Okay, check the performance of the concrete. Whatsoever product which you are using for a particular application, with the same cement, maybe the cement manufacturer, ensure that he does all this R&D at his R&D level and go and convince the customer. That is the right way. So that is the nowadays what I am doing. Like between infrastructure projects, as a consultant, I tell them, please have even a small contractor, please have a concrete lab, a small concrete lab. Have one quality engineer. Okay, have some basic equipments. Okay, the basic equipments. Periodically you check the quality of the cement in the concrete. So there should not be any variation. Like the quality engineer does all this work and all, so that you will not end up with any problems. You will not have any problems. So this will not cost much also. Many of the small contractors, they never does that actually. They doesn't have a proper compression testing machine. Okay, they simply rely everything on the cement manufacturer. Whatsoever they give the cement, they mix it, they supply the concrete. If some problem comes, you have to revert. But then we'll go and say the post-mortem, this is what. So this is we need to look at in a very broader perspective. That is what I want to emphasize. For motor testing, okay, requirement as the individual material is concerned, but ultimately it has to see the end user requirement in terms of the concrete action. That is what I want to emphasize. Like if you look at the market requirements valued by the customer, and also like the concrete standards requirements, less than 10 hours. Sometimes you need to have the early strength. Okay, with the 20 years, sometimes early strength won't remove the early form work. You can have some various applications. You can have various tools to do that. Okay, and also the project-specific solutions have to be elaborated. This is what I want to emphasize. It should be more of a project performance-based, not the prescriptive standards. Okay, it should be more of a performance-oriented rather than the prescriptive oriented action. So, like he mentioned that, I'm happy to know that Ramco is coming up with all this. That's a very happy note. The cement manufacturer is doing that. Okay? And like I want to tell one thing, it's not that I'm promoting Ramco. Like that, I have another 5 webinars for other cement division people in the coming 1 week. But truly speaking, yes, Ramco product is really good. I'm not it's because I'm the professor in charge. I'm constructing my second phase of construction at IIT Bhubaneswar. It's 900 crore project, and your Ramco PPC product is a wonderful product which has been a proven product in my IIT Bhubaneswar lab. And simultaneously, apart with that, we have tested another 5 cements. But your cement has really valued actually. The cement is really doing, and I told that we have done at least couple of times. I told my director was also very happy, and I told that for the whole project, please use only Ramco PPC. Okay? I'm not here to promote Ramco. I'm just telling you this should be so. And the product quality is really consistent throughout actually. Okay, we have tested sometimes. These people are also testing, and the product quality is really consistent. That is what I want to. So we should work in that perspective. Now coming to the market development grades, yes, these are all like is individual this thing, yes, the low like for various applications. Now when you come into the concrete market, you have a huge market in the concrete. Like for the masonry, the plastering works, the small things, the market is very low. But the cement manufacturers, they have a very high market. Okay, very bulk market when you come for the concrete applications. Okay, the huge amount of quantity is going on, and India is a developing country. Okay, in the coming 20 years, okay, definitely we have a huge role to play. And also, it's not that another thing is like advanced construction technologies are coming up actually. Okay, so that is a wonderful sign. So that because of all this, you could able to complete the construction in no time. A big high-rise structure which you are not realized earlier, you could able to come up in 2 years. The whole structural work they're finishing up within 2 years actually, just because of all these advanced construction techniques. Okay, and ultimately the general use, the requirement should be okay. What might be the general use? The project specific. This is what the final I want to emphasize, and the niche application requirements. Because somebody is asking, and let's say you're using a source or own cement, and you said that somebody just said I want a self-compacting concrete. Use your own cement and develop a self-compacting concrete. Somebody says I want a fiber reinforced concrete. Use. So you have to come up with the new products. We call it as the niche products for various application needs. Okay. So you develop the product in such a way that okay, your cement product such a way that so that you will have the right recipe at the end of the day. So some of these requirements ultimately the owner is the owner who's taking the quantity, whatever it may be. He has to, sorry. These are all the specifiers. The contractors always look at the testing and the curing and the environment and the placing and all. The readiness for him, the mixing, the transporting, and the time, the batching and all this. This is more important for a ready-mix concrete player, and for the contractors, this is more important. The placing, testing, and the remove the formwork. But ultimately, for the owner, whatsoever, ultimately the quality is more important for the owner. Actually, the performance of the product, the quality is more important. You need to have a quality structure. It should have some high service life actually. Like a small description about the cement constants, we have seen that. Okay, cement. If I'm just going to skip, not take much of a time. So we look at the individual quality cement. You see the cement. We have a clinker and a gypsum, and the gypsum is added as a set regulator. And sometimes we'll be adding this metal components MIC. Okay, we call it as the fly ash or the slag. So this for a cement manufacturer, the production of the blended cement is by either compound grinding. Actually, they grind it. They intergrind these the fly ash kind of manufacturing, and you have a product. We have a product which is a blended cement, which is then blended inside the cement actually. Okay, these we call it as and the clinker. Definitely you have all this. I'm not going to take much of your time. These are all the 4 primary compounds, and if you look at the CF for the technical interest, this is the strength giving compound, and the C2S will talk about the early strength requirements, and C3A is more of a setting action. The setting time of the concrete is dictated mostly by the C3A, and C4AF we have not understood what exactly is it till now actually. Okay, so this is what the raw mix design, all this. Definitely instead of its content only some 5%, but this dictates most of the problem. The setting time, the strength, the workability, the stiffening. This is very important actually. So why there is a lot of variation? Because the compatibility. Okay, the compatibility because each manufacturer is using his own gypsum actually. The type of gypsum, the type of the gypsum which you are using in the cement maybe is the basic reason for this incompatibility with the mixtures. So you have to know what exactly the gypsum you have used. Okay, and the gypsum content in it. That is the role of an admixture manufacturer. Whenever you take the product from a cement guy, you take the first. He has to assess the cement. What cement is using in the application. He has to formulate the product. He has to develop the product in such a way that so that it should have a very good interaction with the cement whatsoever. It is all these incompatibilities comes from the amount of the gypsum which you are using in the system. So the amount of the gypsum in cement is common related to the clinker content. So this is what the gypsum like. As you increase this content, SO3 content, there is an increase in the compressor strength. Okay, sometimes the 1 day, 3 days, 4 days, and the 7 days, and the 28 days. Okay, so we need to have an optimum component somewhere actually. Too much of adding the 5% whatsoever actually. Okay, at the same time, what do you call? This should be compatible with the cement actually. That we need to work out in the lab actually. So the SO3 content plays a very significant role. Okay, as far as the strength development and the setting time of the cement is concerned. The mineral components, yes. What are these mineral components? You all know that these are all cement constants, which are not derived from the clinker production. Okay? So what we are including in that? Okay, we are using either the blast furnace slag or the fly ash which has been interground. Okay, and interground with the clinker and the gypsum actually. Okay, and what are the mineral components? Look at the classification. Okay, the latent inert materials like we have this blast furnace slag. Okay, and the class C, these are all cementitious. These inert materials, though we call it as inert, the blast furnace slag and the class C fly ash, these are all the cementitious in nature. Okay, they have got some lime in it. Okay, they doesn't depend completely on the cement hydration. So these are all alkaline materials because of the lime in it. Okay, and they have some similar composition of clinker. Like you take a blast furnace, like you mix it with water, definitely after some time it hardens. I mean, it has some hydration phenomena because of the lime in it. Okay, the only thing is it requires a small amount of fish, some activator to promote the hydration. Okay, you can use a small amount of cement or a lime or an alkali. Now coming to the pozzolanic materials like the silica fume or the class F, there the class F this class of fly ash it doesn't have, which has got a very low lime content. So as a material, it is completely inert material. Okay, individually it will not perform on its own. So it requires the help of the cement. So it can harden only in the presence of the lime. Lime is some cement, or some, if you want to individually, like geopolymer we're talking about, some alkaline activation should be required. Geopolymer concrete, this is what the concept that developed actually. The fly ash, and we have an alkaline activators to activate that. Or else, if you are using as a cement replacement material, definitely it has to take the complete help from the cement. So that is why we call it as a pozonic materials, which has got a very low lime content. Same was the case with the silica fume. It has got a very high reactive silica, but at the same time, individually it will not perform on its own, but it will perform only when it comes in contact with the cement. It takes the help of the cement. Like other inert materials, like we have this limestone dust and all this, which some people are using for the research. They can also do that. They will not. They simply fill the they simply fill the voids of the concrete, but they will not contribute to any strength development. And this is what some of the requirements. So 30% replacement, the same water cement ratio. You see that some of this role of the mineral component, the slag. You see this. Okay, in the class C fly ash, in the class F, they could able to achieve a strength of around 100 MP megapascals. This is what we need to look at. The blast furnace slag I will not take much about. So if you look at the blast furnace slag actually, so we have GBFS we have, and after it has to be interground along with this. It has to be grinded. Then we call it as the ground anodized blast furnace. So this can be used for all the cementitious applications, like for regular applications. Okay, the other thing is a air cooled slag and a pelletized. They can be used for the lightweight aggregates. Actually, this application is different. Similar for the fly ash, we know this fly ash. Okay, we have this bottom ash and this, and the ash which flies off, we call it as the fly ash. Okay, it is collected in an electrostatic precipitator, and this is what fly ash looks like actually. Okay, they're all spherical in shape. It is a wonderful material. The fly ash is a wonderful material. Only the performance, okay, in the concrete, but at the same time, because of this ball bearing effect, because of the spherical shape, it gives a wonderful ball bearing effect in terms of the fresh properties, in terms of the workability that we need to. It's a really wonderful material nowadays. Like some of the applications, like we're developing some mixed designs for high-end applications, they're literally using fly ash for making the self-compacting concrete. And it's a wonderful material for a highly flowable and a highly. If somebody asks for a self-compacting concrete, please go and use this fly ash along with some metakaolin or something and all.
In fact, there was one question actually, sir. One question whether fly ash can be used for self-compacting concrete. In fact, you have answered the question now.
Yeah, it's without any hesitation, because of the particle shape, sir. Particle shape, it is giving a matching performance, wonderful performance. Because the self-compacting concrete, the prerequisite is only at the fresh state. It should be flowable. It should meet all the self-compacting requirements, and fly ash really plays a wonderful role in that touch. Because of all the body effects and all, it is really going to play a wonderful role. Okay, without any hesitation, we have used in many projects for where I given the mixed designs. Okay, somebody asked for a high strength concrete, use metakaolin also. My suggestion is a technical suggestion I'm giving. Fly ash, use a small amount of fly. Somebody is asking for a 70-80 megapascal self-compacting concrete. We have done. Without any hesitation, use metakaolin. Okay, this metakaolin is a wonderful product which we have proven in my lab as far as self-compacting concrete. This combination of metakaolin and fly ash in with some other good cement, definitely we are going to get a wonderful, wonderful self-compacting concrete. Please use that without any hesitation. Okay, and coming to the hydration, we are not talk much about that. So hydration, we know the H.W.F. Taylor is a famous cement chemist. Okay, okay, he is the term hydration denotes the totality of the changes that occur when an anhydrous cement or one of its constant phases is mixed with the water. Definitely, when cement comes in contact with the water, okay, a lot of volume changes takes place. Okay, that is we call it as the hydration, and there is an increase in the volume. Okay, so this is what the main features of the chemical aspect, the hydration reactions, and we all know this. We have this HCl, calcium silicates. We have seen that that comes in contact with water. We have a CSHL and a weak compound called the calcium hydroxide. When you blend this any material, a fly ash or the slag, this will be consumed, and in the blended cements, you take the fly ash or the slag cement, the more complex reactions, but you will get this similar hydration products actually. Okay, and the mechanism, the kinetics also vary actually. The heat of the hydration. Okay, the ordinary Portland cement is the average heat. Okay, and the blended cements normally a relatively less heat than the regular ordinary Portland. So this is what the advantage you have in the blended cement actually. Okay, because you're replacing a part of a reactive product with a part of an inert material like a slag or a fly ash, definitely the heat of hydration comes down. And this is one of the beautiful aspects of this blended cements. And this is what the physical aspect, if you look at workable for hours, you have to modulate the cement in such a way that developing the strength, the change in the specific surface area over a period of time, once it also, there is a 100-fold increase. Okay, so like the string into the gel-like product, okay, extremely high surface, and there is an increase in the solid volume. Okay, so if you look at 1 meter cube of cement comes in contact with the water, you get 2 cement meter cube of hydrated cement. This is definitely there has some volume changes. And this is what the volume of the water I'm going to see. And after this, it becomes a cement stone. There is a slight increase in the volume because of this gel pores and all this. Okay. And this is what the reaction we have this. The low water cement ratio, this was the reaction. The certain few hours, the hardening this, and this is what the high water cement ratios it takes over a period of time actually. This is what the phenomenon. Okay. And this is what the clinker, if you look at what is a clinker, is a sintered material produced by burning a blend of raw materials at high temperature in a kiln. And it has got all these main chemical reactions, and these are the 4 primary compounds which you already seen that. Okay, and these are all abbreviated as CS. You know, we all know that. And these are the hydration products. You see the individual, if you look at individual, they comes in contact with the water, and this is what the volume they increase the hydration products. The hydration of calcium hydroxide, we have seen that. So both the C3S and C2S, when they comes in contact with water, you get this CS gel, and they both release. This is a more amount of calcium hydroxide than this. Okay, the hydrated PC contains about 50 to 60% of CSH hydroxide. When you use the blended cement, what happens, which you're going to see subsequently, this will be almost consumed, and that is why you go a gel. Because of that, you're getting all this high performance and all. And coming to the gypsum, yes, the C3A, it forms this ettringite. Okay, they react with the calcium sulfate. Okay. From gypsum to form the ettringite. Okay, they initially because of there is a slight what do you call volume, and it shows the hydration, and different rates of calcium sulfate can be present in the cement with the different solubility. That is what nowadays people are using. Different. So because of that, they're getting some different as in terms of this the setting and the initial setting and the final setting. So that is what. So the amount of soluble sulfate available to react with the C3A will decide this. And this is what the C3A, most of the amount of gypsum, the type of the gypsum and the amount of gypsum which you are using will decide the setting time of your concrete, setting time of your cement. This will not touch much the role of the alkali the concrete. Because of that, when the steel is placed in the concrete, because of this alkali, the K2O and Na2O, you get a very high alkali, and the steel is highly protected in RC structure. Steel is highly protected in a cement concrete because of this alkali in it. Okay, and this is what the hydration can do. You see the heat of hydration. The C3S reacts much faster, and C2S the late, and immediately C3 also reacts faster. Okay, and this is what the individual hydration performance actually. Now coming to, if you correlate this, suppose you have a blended cements, you see this OPC, initially you see the strength is somewhere in this range. The blended cement, the slag and the fly ash, you see this, the heat of hydration is pretty low compared to this. Okay, the heat of hydration is very low compared to this. Okay, and this is for some of the applications where the heat of hydration is a big basic problem. Like this, as from a cement manufacturer side, you can have a low cement fineness. Okay, you can have adjust the cling. You can modulate the product in such a way that. Okay, and that is why we have this low heat Portland cements and others, low hydration temperatures. And nowadays I say that no need of product called a blended cement actually. Definitely go and use this blended cement in your or a slag based cement, what is the Portland cement. Simply go and use that. Okay, definitely it will address requirements. Yes, and of course nowadays this is another basic problem which has seen very recently and not recently in the last couple of years. This grinding the fineness. This I noticed in most of the blended cements actually. This is the problem I have seen that because what happens sometimes some of this are not specifying the names of some of the manufacturers, because see that whenever you're having a 30-35% of the fly ash quality should be of good reasonable quality, good quality. so that you will not have all these problems of the grinding the cement. Sometimes they use a very bad quality fly ash, and because of that, what happens, to match the performance of the cement to that of an OPC, they grind the cement to a very high fines. Okay, so that they have the more early removal form. That's good. But the thing is, you see that the heat of hydration also shoots up actually. Okay, even sometimes in some of the cases I've seen that. Okay, some of the cases I've seen that you see in the blended cements, though in the earlier slides we talked about the rate of heat of hydration is very low and all, but so definitely, when the rate of heat of hydration is very low, definitely the shrinkage won't be that much. But when you have a very high fineness, you see that the heat of hydration, no matter whether you use a OPC cement or a blended cement, definitely there will be some heat of hydration will be slightly more. Because of that, even the blended cements also they're showing some cracks the next year. So we need to have a very balanced fineness. So this I want to tell the cement manufacturers. Okay, business is one thing. At the same time, it should be you have to see the application also. So you have to modulate the fineness in such a way that it gives the right performance in terms of the shrinkage as well in terms of the heat of hydration. So this acceleration or retardation, you can use nowadays. The no concrete is without an accelerator or a retarder. Everyone is using this chemical admixtures in the every concrete manufacturing. I can use the accelerators or the retarders. Okay, cement fineness you can model the cement fineness as well. Okay, these are all like definitely you see the heat of evaluation. If I have a cement which is having the amount of heat it is, and if I have see the fineness 50. See. So the initial first 5 to 10 hours plays a very significant. This is very crucial for me. This dictates most of the properties. After that, you see all the 3 curves are almost similar. After 1 day, after 1.5 days, these 3 curves, this is not a concern for me. The first very few hours, what the cement hydration takes place, that is a big concern for any manufacturer, any end user actually. Because if you have a very high fineness, you see that this is what the heat evolves, and definitely there will be a lot of silver cracking. Okay, so that we need to look at. And definitely like some of the strength, this thing, the heat of hydration and all. I'm not going to touch much upon this. And the low heat of hydration, like especially the mass concrete structures, which already covered, at least for the cement or so you can use that. And coming to the strength development, if you look at the individual cement, there are standards, the various standards are there. People talk about this mortar strength and all this. Okay. And coming to the strength, like it depends actually. Suppose you have the early strength which varies from 20 megapascal depending on the composition and the reactivity. Okay, and so the late strength of the clinker. All these things you can work out actually. You can model the product and work out on all the products. Okay, and also the early strength of the cements actually. You see that the clinker content is very high. You see this the early strength. Okay, and the compressor strength is also fairly high. It's a completely Portland cement actually. And individually you see this fly ash and all nowhere actually. Okay, individually they are low, but over a period of time the strength will shoot up. So this is what the Portland cement and this is what the fly ash cement and all this and all. But over a period of time, this at a particular age, after 90 days and all, this the strength of this will be relatively high. Now coming to this, like I already mentioned that the cement strength is basically most on the standard mortars. Okay, but truly speaking, in the concrete, I just want to tell once again, but in the concrete, when you're using the concrete, there are other things. The aggregates comes, the admixtures comes, and people talk about the consistency, people talk about the water cement ratio, and people talk about the placing temperature as well. Okay, all these things will come into the picture there. And in the concrete, this scenario, what all you have seen here in individual cement, the statistics will differ when you start using in the concrete. So my thing is, if the requirement is like this, it should also have the same requirement in the concrete. If it is performing in the similar fashion, it should also perform in the concrete in a similar fashion. And this with a reasonably good quality materials. That is what I want to, at the end of the day, this I want to emphasize actually. And these things and the properties of the OPC blended, we know that okay, the Portland cement, okay, they ultimately get the calcium silicate. This gives the strength giving compound. We're going to see that. This is about that. Now coming to that, durability. Okay, ultimately we talked about the cement, we talked about different blending materials and all this. Now coming to the durability, I told the strength-based design has been replaced nowadays by the design centered on the durability of the concrete. Okay, and this I got it from this slide. I got it from Manu Santanam from IIT Madras. So he has given this slide. And the strategies for concrete design have changed over the years. Okay, so everything is centered on the durability, performance, durability, performance. This is a slogan everywhere right now. Okay, strength is not at all a concern. And of course, we all know what is the meaning of the durability. Actually, I don't want to waste time on this. So if you look at it in a nutshell, it will regain its original form, the quality and the serviceability when exposed to its environment. I want to tell you one more thing here. Like the durability of the high performance means like the experiences which I get when I give some presentations outside. People always think that they're talking about a high performance concrete. They're of the opinion, some of the government engineers which I've interacted with, they're of the opinion that means this concrete will last forever. This lasts forever. See, the meaning of this service life, the durability is, okay, let's say with OPC cement, your service life, let's say your first crack, your first, let's say the first distress, maybe you have, let's say you have noticed after 15 years, let's say. When I'm using a durable concrete, okay, it doesn't mean that it will not show any crack. It means that I'm prolonging my service life. Instead, it shows the first distress at 15 years, it may show up 25 years. That is what we're trying to enhance the service life of durable concrete. It doesn't mean that when I have a high performance concrete, it will be there for 80, 90 years. Definitely your service life is 80, 90 years, no doubt. And nowadays you see this, all these metros which are designing it, all these last for 80, 90 years. That is what they have designed it for. But at the same time, okay, that is what the calculations they have done, the theoretical calculations. Of course, the concretes also which are used in their construction, they also have proven in the lab that they will resist for 80, 90 years. At the same time, you should have the periodic maintenance. Okay, if you, let's say, have made a very high performance structure initially, okay, then I'll keep quiet. The structure will take care of everything. It's not the thing. Okay, it should resist. At the same time, you should have some fund available to have all these maintenances. Okay, whenever you see some distress, immediately you maintain it. Definitely, it will come down. Immediately maintain it. Definitely, this is how you're going to increase the service life of the concrete. Okay, and so because see, like we do have a age factor, like we do have age. You'll not you'll not be like a 20-year-old guy throughout your life. At 100 years, like, even though you're healthy and all, at 80 years, nobody say you look like a 20-year-old guy. Because there is a factor called the age factor. In spite of you're a very healthy person, there is called the age factor, and that is applicable for the materials as well. So the periodic maintenance is very required. So then only it should go simultaneously. You'll have the high performance concrete, good maintenance. Definitely, the structures will last forever. And some of the durability problems which issue that, so the properties of blended cements depends on the clinker content. The replacement of the clinker may either improve or deplete the properties of the parent protons. It all depends. So typically, most of the problems you see that they may reduce the early strength, but it increases the chemical resistance and the durability. The early strength. So by anyhow, nobody like nowadays some of the structures up to 14 days and 20 days, you're not going to remove the former. That's not a concern. But ultimately, if you have the right compaction, right mix design, right construction practices, definitely the durability will improve. Okay. So proper cement design limits undesirable effects and enhance the advantages of the MACE. So we all know this pozzolans and all. The cement, the pozzolanic reaction. Okay. This is the calcium which you see. This I got from one of the company, earlier company. OPC, the comment reacts with the water. Okay, you will get a hydration product called a CSH gel. Okay, and you get a weak compound called a Portlander or the calcium hydroxide. Okay, when you add a fly ash or a slag in the system, what happens? Now, this is basically a strength giving compound. This I got my earlier company, and this is basically a weak compound. When I add it to the system, actually, when you add a fly ash, definitely what happens? It reacts with this calcium hydroxide. The fly ash reacts with the weak compound, and it converts to another. So this is CSH1 and this is CSH2. So we have another additional compound called the CSH2. So what happens? The weak compound has been replaced by another strength giving compound, which is nothing but the calcium silicate hydrate. Okay. So because of that, that is why if somebody asks you what is the reason, you all might be knowing what is the reason when I add this fly ash or the slag in the system, why my durability is improving compared to OPC. This is what the basic reason actually. Because of this, we call it as the pozzolanic reaction. And this whole calcium hydroxide will be consumed completely, and this will be replaced with another strength giving compound, which is nothing but the CSH gel. Because of that, the pore gets refined. The large pores will become small pores. There will be a lot of pore refinement. Okay, and the structures will become structures will become highly durable actually. This is what the thing actually. And this is what the light can be reduced definitely. And this some of this comparison of workables of various cement types, which I got it from somewhere actually. You see that the clinker, the OPC, this is what the reaction. Okay, the clinker has increased the clinker. What happened? The motor flow. This thing. When I use a fly ash on this thing, you see that you have a fairly consistent motor flow. Actually. The setting times also the same was the case. The influence of the clinker, we already seen that. Sorry, it's got repeated. But this time you see that I already told that is a very old slide. You see that this is a cement type 1. The cement type, sorry, which is nothing but a OPC. We call it as OPC as per the ASTM specifications. A cement type 4, which is a slag cement, or if I don't remember, slag cement or fly cement. Initially, okay, they show a slightly lower strength, but over a period of time, they surpass the OPC cement. It just
ultimate strength is more.
Ultimate strength is significantly more, maybe the PPC or the slag cement. Over a period of time, they surpass the OPC, and the ultimate strengths are relatively more compared to the OPC. This is what, apart from the ultimate strength or more, it gives a very high, durability as well. Somebody is asking for a chemical resistance. 1 second. Sorry. Yeah, this leaching actually. If you talk about leaching, let's say if you take an OPC cement, one of these, just now I've seen a question.
Leaching.
Someone is asking about this leaching. Yeah, leaching is basically like, suppose if you use a pure ordinary Portland cement, we have seen the reaction. Now we have the CSH gel and the corresponding calcium hydroxide. Okay, this calcium hydroxide being a weak compound, let's say when it comes in contact with some acids or the sulfates and all, what happened now? Being a weak compound, it gets leached in. The calcium hydroxide, let's say calcium sulfate. Okay, let's say the H2SO4. Let's say take the case of calcium sulfate or H2SO4, a magnesium sulfate. What happens when it comes in contact with the calcium hydroxide? What happens? The calcium hydroxide gets leached away. The whole product gets leaching away. This is called the meaning of the leaching actually. And so when I use this, okay, when I use a blended cement like this, because the calcium hydroxide compound is being consumed by this, the blending material, the fly ash or the slag, what happens? Your leaching will be reduced drastically. That is what I want to emphasize. So reduce hydration to acids. Okay. So what happens? Your leaching compound, which is the calcium hydroxide, is been consumed by your organic material, and there is no material available for leaching. When the acid or the sulfate comes in contact, it will not be leached away. When you use a fly ash or a slag. Sorry. And this is what it's a very old slide. I like the wonderful researcher is Masaja. So ultimately, your ultimate strengths are relatively very high compared to the OPC when you're using a Portland Pozzolana cement. And this also you see that this is an ordinary Portland cement. Whenever you use a blended with a fly ash or 20%, 30%, you see this, there is an increase in the strength over a period of time. It age months, you see, relatively this. Whereas you see this OPC, the curve is becoming flattened over a period of time. So this keeps on going on. Similarly, same was the case with the slag cement as well. 40% slag, 50% slag. You see this over a period of time. If there's an ordinary Portland cement, over a period of time, the strength is shooting up. It is in an exponential way. So this is how. So don't concentrate on the initial. The earlier strength are relatively low, but you see the benefit you have over a period of time. Okay, over a period of time. So see, somewhere you want to have a benefit, definitely you have to sacrifice them. Okay, somewhere let's say you want to have a durability, definitely you sacrifice nothing will come for granted actually. So you sacrifice this instead of slightly increase the curing time, definitely you're going to get this benefit. Okay. And similarly, initially you see the temperature evolution without the pure cement. When I use the 30% or 50% pozzolana, you see that the temperature evolution will be very low. So the first few years the temperature evolution is very important for me. So this is most of my early edge cracking of the concrete actually. So adding this pozzolana or the fly ash or the slag in the concrete, the temperatures will also come down, and without any hesitation you can use this for your mass concreting applications. That is what I want to emphasize here. And the creep role, of course, definitely the creep, if you have no replacement, it's slightly low. There will be slight increase in the creep because of this low this thing and all. But over a period of time is matching the depth. Okay, that is not a big issue at all. Creep is not at all a big issue. Durability issues, each one has its own issue, the scope, the target, and additional. If you have a sulfate resistance, you have a problem with the sulfate resistance, okay, avoid this. If you have a low heat of hydration, reduce the heat development, minimize this one. This is what the people are using earlier, actually, for each and every application, new product, low heat Portland cement, rapid hardening Portland cement, all this cement. First, if you want to have a leaching resistant, avoid leaching of lime, minimize C3S. If you want to have an alkalis silica resistant, minimize alkalis, avoid alkalis. Then nowadays, that is, we don't require that much. All these things can be addressed in a very this thing. Okay, this is what the OPC way. This is what the OPC way they're trying to look at. The earlier scenario, but things have changed a lot nowadays. Okay, so like we have a sulfate resistant cement, low heat hydration cement. All these different products have come for various application needs. But now this is what the OPC way. But now when you have this blended cements, what happens? Okay, when you have these metal components, they reduce the amount of the clinker in the cement, they reduce the porosity, they decrease the heat of hydration, and all these things which are will be addressed by the blending material. So they will take the fly ash or the slag. All these things will be addressed by the fly ash or the slag system. Okay, so this is what the blended cement is. Okay, all these concerns what you have seen in the earlier slides, all these concerns which you have seen earlier, they will be nicely addressed by this blended cement. So my thing is use blended cements as much as possible in all the applications. Okay, in all the applications, in every application, in the right way, the right recipe. Another problem which I am seeing in the construction is the compaction of the concrete should be good, because in the last 3 years being campus, I tell the contractors, even though the recipe is good, but it's not been handled properly at the site. The product properly at the site. And so what happens? You talked about a wonderful product. You're talking about a blended cement, and with cement, what a wonderful concrete product. The product has not been handled properly, and we're talking about a low impermeability concrete, low porosity concrete. If it has not compacted the concrete properly at the site, construction practice is more of a construction practice, not a technical aspect. It's not compacted the concrete properly. What happens ultimately? We have a honeycombing disorder. You have this void zone. Ultimately, what all which we are seeing in the slides, what all I told about this, the beautiful slides here will not be reflected on the real-time situation. This is the basic problem which I have seen in the last years when I'm building my campus. So these construction practices, I tell the cement division people, okay, who are selling the cement, the technical, especially the technical services team, apart from selling a product, apart from giving some technical assistance, educate the customers as well. Okay, and make them understand the importance of the benefits, make them understand the importance of the construction practices. That is very vital. What I have realized very lately, the construction practices should be good. The same product which has been the same recipe, same material, everything which has been a proven product which has given a very high performance in my lab. When I'm reflecting, when I'm transporting that the same product for my real application, it is not performing there because of the lack of good construction practices. So this is what I want to tell once again. So definitely, coming to the curing, the concretes cured with blended cements must be carefully water cured in order to fully develop their potential. That is what is not. Yes. I'm going to wind up another 5 minutes, sir. Yeah. So if not properly cured, what happens? Some of this will remain as a filler, and what all the slides which are seen till now, okay, is of no usage. And this is what you see this, the properties of the CHL, you see this compared to OPC. So a lot of pore refinement is there in this. The large pores, they're becoming the fine pores. They're becoming fine pores, and they're not interconnected. This is how the durability increases. And also the sulfate attack also, all this you see this, 50% slag and all, they're giving a very low expansion. They're giving very high resistance whenever using the blended cements. Similarly, same as with this chloride attack also. And this some of my lab results, you see that the corrosion rates, we have done some of the corrosion rates for a steel which is there in a blended concrete. Whenever you are using a PPC cement, okay, the corrosion rates are 50% lower than that. Definitely your service life will also be improved by 50%. Same was the case for the slag cement as well, the frost resistance as well. So if you look at the difference between the blended cement and this blended concrete, okay, with the blended cements, the optimum adjustments of the components and the design should be done at the cement system. The better quality control should be adopted actually. The consistency and the quality of the cement should be good throughout the whole application. So if you use in the concrete, more flexibility in the concrete composition, that is very vital. The homogeneity of the concrete mix, this is very important. The homogeneity of the concrete mix will come when there is a minimum. The concrete mix will come definitely when there is no variation in the quality of the cement. If you have a fairly relatively, suppose if you take a curve like this, the quality should be fairly relatively good. Definitely, this will be reported in the concrete. Then the homogeneity will not be affected. The longer mixing times will not be. So concrete performance for both the equivalent should be economical and the commercial factors should be worked on. So if you do this and if you look at the marketing, so definitely whenever it's manufacturing the cement, output the same clinker production. This is a business strategy, no doubt. At the same time, they have to get the credits for using these raw materials. Definitely, they're using the fly ash and the slag. Recycling the byproducts and the cements, they're really preserving the environment actually. And this is what we do look at. And this some of the conclusions, okay? That's it.
Yeah, thank you so much, sir. In fact, just to give a brief overview, you had given the qualitative advantages of using blended cement, and at the same time, how much of environmental contribution that has, that leads to, because every kg of blending material that we use, that much of CO2 is avoided. I mean, that is one of the most important aspects as well as the environmental parameter is concerned. But more importantly, what I believe is the qualitative factor in terms of enhancing durability, in terms of reducing leaching, in terms of lowering heat of hydration. You had explained very well. In fact, some of the questions that the participants had asked.
Any queries?
Yeah, can I just take up a few of the questions so that practical questions also they have got. Are you able to hear me? Yeah. So the thing is that one practical question: can we use dust instead of sand in concrete? In fact, which is not advisable.
What is the question? Dust? What?
Can we use dust? That is, instead of sand, the question is: can we use dust? Quarry dust.
You mean quarry dust? Okay, quarry dust. The quarry dust, yes. See, I cannot say that. See, the issues like quarry dust, like. So nowadays, see now, like take the case of this Mumbai. Nowadays, they don't have natural sand now, and they are most of the investigations they are doing on this quarry dust only. Yeah, most of the investigations they are doing on this quarry dust and all. It can be used. See, it has to be a proven product. Okay, it's not that dust company I can use 100% dust. It should be blended with some natural material. Natural sand can be blended with that. So we have to use the right way. Actually, okay.
I'll just tell my experience also, because most of the sites what they do is that, in the name of sand, they start using dust, which consumes more of water in the concrete mix at times and leads to more shrinkage as well.
Yeah.
So that is one of the practical issues. And second question which they were asking is, suppose there is so many advantages of using blended cement, then why is it that government specification talks about OPC 43 or 53 grade only? Because we as a cement manufacturers also supply, OPC 43, 53 to various sites, and they blend the blending material at site. But the thing is that why not government departments are specifying blended cement in their specification? That is one of the questions that had come.
This is the problem, no? The government engineers, no, they're tuned in that way. They're very scary people actually. They always go with the specifications and all this. But recently, sir, I will tell you my experience. Very recently, I educated many of the customers. In one of the applications, they came to me. They're still using the very old 1970, 1980 method. They're using the sulfate resistant cement. I asked them, who is giving the sulfate resistant cement? And he showed me one cement company which I have not heard in my lifetime, the cement company. Please don't use that. I educated all this, it's some defense project. I educated the MES people. Please go and use slag cement there. For what application you want, please go and use the slag cement. If you want, I can give a letter. You come from IIT professor, you go and show to whosoever people, you can go to and show to your work. Then after that, I give the mixed design. They started using the slag cement. So this is what the mindset has to change actually. But I don't think so. This is a problem, sir. Earlier this was a problem, But recently, in many of these projects, I've seen many applications, the road construction, some of the constructions, the government people are allowing this PVC and all, PSC cements, no problem. I don't think it will become a bottleneck now. Yeah. This was the scenario earlier, actually, a couple of years back. Yeah.
I think now it's changing slowly.
Yeah, definitely it's changing. They're also
I think you also brought out that aspect of application-oriented concrete usage based on which cement has to be supplied. That is very important because our experience also shows when we were supplying to various RMC units in various cities, they were in fact transporting concrete. In some cases, they wanted slump retention of up to 2 and up to 3 hours as well. So we needed to have a kind of cement where cement and admixture both are very much compatible, and they are able to get that slump retention. I think that is one of the most important practical aspects that we need to realize. And we have been doing the trials also at our research center, and we have been able to give the solution to many of the RMC units. I think that is the perspective that we need to look at. That's a very important point that you raised.
Because these are, because whenever I go to any such some problem, most of the problems come from the concrete.
Correct.
Any RCC structures construction. This is what I want to emphasize. I hope I have made you understand all this.
Yes, it was. I think, in fact, what you said, there were some questions also, like say in case of PPC cement or blended cement, should we delay the removal of formwork as compared to a concrete made with OPC? I think it is more to do with concrete strength rather than with the type of cement. If you are able to get a concrete strength which is able to gain strength quickly, I think you can go in for the removal of shuttering and all that. So that is why you will find even in our PPC, this thing, we have a PPC cement which is having a lower strength, as well as we have a premium PPC cement which is having a compressive strength equivalent to OPC 53, because this is based on the various customer requirements that we have made. Like say, for example, we have the Ramco Supercrete, we have the Ramco Supergrade, the Ramco EFC, and 4 types of brand within PPC itself, just to take care of the customer requirement of this kind of thing. And another important question was related to curing time. What is the recommended curing time for concrete?
See, as of now, nowadays, what we have seen, it depends on the what element you're in. Suppose the slab element, you're using for the slab element, go as per the specification, as per the Indian specification. That's it. Because nowadays the blended cements, maybe if you feel that if you want to cure it for another 3 more 4 days, it's good. If you doesn't want to reuse the formwork once again, if you have ample time, you cure it for another 3 more 4 days. Actually, that's not at all a concern. Actually, but as my suggestion is, go with as per the specifications. Like the slabs, you want to remove the props I showed you in the beginning, the 14 days, normally 14 days to the 21 days. Do it judiciously, all the curing processes and everything and all, even with the blended cements. Then after that, definitely in the blended cements, 60 to 70% will be achieved by that. In spite of after removing the props, also start curing the elements for another a week or 10 days. Okay, we should not avoid this curing. Curing plays a very significant role as far as the blended cement concrete is concerned. Actually, this is very important actually.
Thank you so much, sir. I think you have covered most of the point, and I'm sure that we have a good association between IIT Bhubaneswar and Ramco Cement, since Ramco Cement is being used in most of the works in IIT Bhubaneswar, and we have been able to have a good interaction, and thanks for taking up your time and interacting with us. In fact, we have been following most of what you have been mentioning in the slides, in terms of most importantly, looking at the application perspective, looking at the concrete properties, and doing more work on application-oriented studies rather than purely research work. What is important is what is happening at the site, and it needs to be incorporated in the research. That is what we have been doing at our research center as well. I mean, some of the very important points that you have used, and most important question, many of them were asking, can we use chemical admixtures with blended cement?
Yes.
It has, in fact, it has been used. In fact, if you look at the blending material, say for example, OPC and fly ash, admixture is being used for slump retention and all that. So that means it can be used. There's nothing wrong in that. Many of the sites are using chemical admixtures along with blended cement, or OPC 53 or OPC with blending material and chemical admixture is being used. So only thing is that we need to have a sufficient number of trials done before actually being used to look at whether we are getting the performance or not. And that is one of the most important times. So thanks a lot, sir. It was a good discussion, and thanks participants for your questions. And if there is some more questions which has been not been addressed, you can always send us an email, or you can get in touch with our MACE engineer, who would again give us the question, and we would be reverting back with the solution through email as well. So thanks for your time, sir.
No problem.
And thanks for all the construction professionals who have joined us. If there is anything, you can just anything else that needs to be covered. I think
that is what. Thank you for this opportunity.
Yeah,
I mean, thank you so much for this opportunity. Okay, thank you so much.
Thank you, sir. Thank you so much, sir. Thank you, and thanks the participants who have been very enthusiastic and you have been posting your questions. As the speaker had just mentioned, based on various applications, all of you would be aware, 12 different brands of cement being manufactured by Ramco for various types of construction works, be it a multi-storied building, be it a bridge, or be it a concrete road. Our cement has been going for various applications, and we at Research Center have been helping many of the construction professionals also to make a concrete which fulfills their requirements. So with those few words, I thank all of you. All the best, and let us interact again in our future webinars. Thank you so much.
Thank you so much. We'll keep in touch. Okay?
Yeah,
thank you.
Sure. We'll keep in touch. Thank you. Hello, Ramachandran. Hello. I think we can. And,